In this example, we're looking to smush three integrals into one. We want to write this as a single integral, so we're going to use what we know about bounds. So in particular, we're going to be looking at the bounds, the numbers at the top and the bottom of our integrals here to figure out how to put this all together. So first off, you'll notice in the first two integrals, we've got -2 to 2, and then our second integral goes from 2 to 5. Because these two 2's actually match up, the upper bound of the first integral and the lower bound of the second integral, we can just smush them together into one single integral going all the way from -2 to 5. So put that all together, and now we are still subtracting our -2 to -1 f of x dx. All right, we're going to have to do something different for the second integral here, because you'll notice, first of all, we are subtracting it, and we only really know how to add areas. We haven't talked too much about subtracting them. Also, notice in this case, our lower bounds are the same, but to piece integrals together, you need the lower bound of one to match the upper bound of the other, like we see in the first line here. So we're going to use a nice reminder here, and that is that if we have an integral from a to b f of x dx, we can change those bounds just by throwing a negative sign in front of it. So basically, anytime you throw a negative sign in front, you can flip those bounds, which is going to be great. So that means we have our first part, f of x dx, and then we can flip our second part. Our negative sign turns into a positive. And now we go from -1 to -2, f of x dx. And now notice our bounds, lower bound and our upper bound, those two match up. We have that lock-in right there, which means we can push these together to get a single integral, and that is going to go from -1 to 5, f of x dx. So there is our ultimate solution there when we smush integrals together. Thanks for listening.